So what I was explaining in the previous session is that I did the generalized version of the chi-square goodness of fit test, in which I considered the following problem, and we have got the observed 2 by 3 contingency table denoting or giving us the observed frequencies, and which have been collected from directly from the sample. And with the help of the formula given over here, we calculated the expected frequency in the similar manner. Now, what we need to do is that we have to calculate this chi-squared statistic by applying this TDS formula, and then we can get our conclusion. Now, we have already used this particular formula in unidirectional case. In bidirectional case, we can take the help of the software if we don't want to do it manually. But the command that I have used in Maple, this command, as you can see, is the unidirectional command. It is not giving you any matrix. So for this goodness of fit test, we have to use the command, a separate command, separate kind of command. And how have I got this command? It falls in the category of chi-square independence test. From there, I have got this command. Now, the way by which the command has been written, the matrix is showing column wise, but we actually want to have a row wise row matrix. So we need to do a little change over here. So let me change accordingly. What are my values? Let me see the values which is given in the chart. The values are 68, 56, and 32. So let me put it over here. 68, 56, and 32. And what are the values of the second row? The second row value are 52, 72, and 20. 52, 72, and 20. Now let me see what comes. So now this becomes your observed row, observed frequencies written row wise. Now we have to form a similar kind of matrix for the expected frequencies. So let us not copy this, because otherwise I have to change a lot. What I can do, I can copy it, and I will just change the value. We can name it as Y. Sorry. Here I have to put Y. And what are the values? Let me check from the problem. The value that I have calculated is this one. Now you have to take this pain to calculate these values. You can have to take this pain. I have not checked whether you can easily calculate the expected frequencies using statistical this statistical software or not. But if you want to calculate, you can take help of different other available softwares, like Excel can easily calculate these things. You can write a very short program in Excel and you can quickly calculate these expected frequencies that I have done manually, because the matrix is of smaller size. Let me put the input. Let me give the values over written over here, calculated over here as input. So 62.4. 62.4, and then next value is 66.56, 66.56, and the third value is 27.04, 27.04. This gives your first row. The second row gives 57.6, 57.6. Then we have 61.44, 61.44, and then we have 24.96. Okay, all the values have been entered, and then we have printed all expected frequencies. Now the command is this one. So we can take this, you can copy it from here and you can paste it. Okay, now if I click on it, what you can find is that critical value comes out to be 5.99. Chi-square degree of freedom is 2. Why it is 2? Because the chi-square statistic that I'm using over here, its degree of freedom has to be, its degree of freedom according to the theory, it has to be like this. It has to be, since we have two numbers, R and S, okay, in this contingency table. So its degree of freedom is given by the formula R minus 1 into S minus 1. Here my R is 2, here my S is 3. So it is 2 minus 1 into 3 minus 1, which is 2. And therefore you find the value 2 over here. The chi-square value is 2 over here. And the statistic that came out is 6.43. If you calculate this these things by the formula double summation over ij, nij minus eij whole square by eij, if you calculate this figure, you will see that it will approximately be equal to 6.43. You can check it. Okay, and what else we are seeing from this calculation? From this calculation, we are seeing that the tabulated value of chi-square at degree of freedom, p-value is 0.04. Here the degree of freedom is not mentioned, but we'll consider, yeah, degree of freedom is mentioned, it is 0.05. So at 0.05, that is 5% level of significance, the tabulated value of chi-square is 5.99. And since the calculated value, that is 6, is greater than the tabulated value, the null hypothesis is being rejected, which is false. Okay. Now you have to keep in mind, you can ask me here one question that since this particular problem is the generalization of the earlier one, what will happen if I consider this previous comment of Maple to calculate this? If I use this command, if I use this command to the current problem, first of all, the observations will be taken row wise in a single row. Expected frequencies will be, if I give it in a single comment, let me show you what happens. Okay, if I don't show, you will not be able to understand. If I try to use this command over here, what is the problem? Let me show you. So I'm using this command. Let me put the values. First of all, I'm going to put the row values, first row values sequentially. And then the second row values. Okay, these are my observed. I can name it differently because otherwise it will not able to understand what I'm writing, because the names will be same. So these are my values written in the following manner. And suppose I'm considering expected value of 3 in the same manner as follows. We can write 62.4, we can take 66.56, then we can take 27.04, 57.6, 61.44, and 24.96. And if I use the previous command, let us try to find out what is happening over here. Why am I showing this? Because you may think that this is the generalized version of the previous one. Why can't we use the previous command? So I'm using it forcefully. And you see all the values that, no, sorry, this is, I have to change. It's observed 3 and observed uh, is expected 3. What I see is that the chi-square statistic is calculated, no problem. It's correctly calculated, the chi-square statistic, because this is also 6.43 and this is also 6.43. Calculation will not be wrong. But what will be wrong is the degree of freedom. What is wrong is the p-value. Here, degree of freedom is considered to be how many values are there? 1, 2, 3, 4, 5, 6. If I consider them row wise. So if I consider them row wise, the degree of freedom is 5. 6 minus 1 is 5. But in this particular independence of attribute, the degree of freedom shouldn't be 5. It should be r minus 1 into s minus 1. So this is the correct interpretation of the given bidirectional problem. This is not. So here you see the null hypothesis was being rejected, and now in this wrong calculation, the null hypothesis is being accepted. So you have to be very careful about what you are using. Why am I so bothered in showing this particular command wrong in a wrong way? It's because suppose you are not studying the theory portion of statistics, and suppose somehow you have got hold of the command of calculating chi-square statistic. One fine morning, you have come to me and you have asked me whether Maple can calculate chi-square or not. I have shown you this example of the above example, and I have shown you, yeah, Maple can indeed calculate this thing. And then you go back and you take the problem of independence and you try to find out this, try to use this command, and you get some conclusion. You will definitely get some conclusion, and on the basis of the conclusion, you are giving your judgment. What is the point of what is your theory? Your theory is that, yeah, the teacher explained how to use the Maple for goodness of fit test, so I have used it because the test I'm using, although it is written in matrix form, it is also a goodness of fit test. But you do not know that your level this degree of freedom has changed. So just getting hold of a software and using it doesn't count. You have to know the theory part. You do not have if you do not have any idea about the degree of freedom in this case, your conclusion regarding the system will be totally false. Okay. So this is the thing. And one more thing, that suppose here they have chosen the level of significance to be 0.05. If I change the level of significance to 0.01, definitely the values are, the null hypothesis is going to be accepted over here. So if I consider the level of significance to be 0.01, the null hypothesis is going to be accepted because it is lesser than the p-value, and 0.05 is greater than the p-value. So in this particular problem is also showing us that same problem can be accepted at one level of significance and rejected at other level of significance. It is quite obvious because it is dependent upon the p-value of the test statistic. Now I'm giving you a problem. I'm writing it on the whiteboard. The problem is as follows. Question is, to sample polls of votes for two candidates A and B for a public office are taken. are taken. One from among the residents of rural areas the results are given below. This is the chart we have. Votes for area. There are two types of area, rural and urban. Votes for candidate A and candidate B. Number of persons in rural area voting for A is 620. This is 380. This is 550. This is 450. Okay, so this is the observation. The question is, examine whether the nature of the area is related to voting preference in this election. Now I ask all of you, it's a very simple table. It is a 2 by 2 table. So I ask all of you to calculate this particular problem quickly and tell me what is your conclusion. You have the chi-square table with you. I am activating the chat box for you so that you can communicate with me. Okay, just a minute. Chat box is activated. Whoever wants to send me direct message, they can. You have the chart with you, statistical chart with you. You can get the, don't have to calculate the p-value, just to calculate the test statistic TS, and you consider the chi-square value at 0.05, 5% level of significance. Tabulated value of chi-square you consider, degree of freedom you calculate, and tell me what is your conclusion. Okay, it's a 2 by 2 table. I hope that you will be able to solve it very quickly. It is the contingency table of order 2 by 2. Now I shall suggest, by the time you calculate the thing, I shall suggest one thing to all of you, is that since we have come to know of various statistical hypothesis testing techniques to deal with practical problems, what I am giving you a very simple task to follow. I don't know whether you are going to follow it or not, but it is I think the simplest of all tasks that I have so far given to you. The task is, whenever you find time from your busy schedule, you take a statistics book and open the hypothesis testing, the chapter where the chapter from which the hypothesis testing has started. Go to the exercise section and don't have to do any problem. Just read the questions. Just give a reading, thorough reading of all the questions of hypothesis testing that is present over there in your book. This particular very small homework will help you to identify different situations which have been dealt by a specific hypothesis testing process. Okay, so if you do this homework, very quickly you can identify what sort of practical situation should be dealt by which sort of hypothesis testing technique. Now, I don't know whether you are calculating or not. Let me wait for at most 3 minutes. If you are calculating, then just write in the chat box what is your conclusion. I want these 3 values from your end. So I have got the test statistic from your end to be 10.08 approximately, or 10.0916 more accurately. So what I need you to, degree of freedom is 3. Now he is writing that degree of freedom is 3. How many rows are there? 2 rows are there. How it is 3, Aniket? How the degree of freedom is 3? It is a contingency table. It is a 2 by 2 contingency table. Should it be 3 or something else? Yes. Yes, you shouldn't do it by previously Aniket has given me the value of degree of freedom to be 3, which is wrong. It is because he considered 4 values, n equal to 4, and he used the degree of freedom formula to be n minus 1. Rather, it should not be. It is a contingency table. Here r equal to 2, here s equal to 2. So your degree of freedom has to be 2 minus 1 into 2 minus 1, which is 1 into 1, which is 1. So degree of freedom is 1 over here. Yeah. What is the tabulated value of chi-square at 5% level of significance? Just look at your statistical table and then tell me what is the tabulated value of chi-square at 5% level of significance. No, that is Nahasal, that is the calculated value. I'm asking the tabulated value. Tabulated value. Tabulated value at 5% level of significance at 1 degree of freedom. At 1 degree of freedom. Okay, so they are writing that the tabulated value is 3.84. Now what we find is that my calculated chi-square is actually greater than the tabulated chi-square at the specified degree of freedom, which is r minus 1 into s minus 1 and at 5% level of significance. So our conclusion is that our H naught is rejected. Now, in statistical theory, why have I made you to solve this particular problem is because of the following reason. In statistical theory, they have given us a formula for 2 by 2 contingency table. If your contingency table is of size 2 by 2, then you can calculate the chi-square statistic with the help of the following formula. The formula is as follows. It is capital N into AD minus BC whole square by A plus C, B plus D, A plus B, my pen is not working, just a minute. Okay, A plus C, B plus D, A plus B, and C plus D, where capital N is equal to A plus B plus C plus D. This formula you can consider to calculate the chi-square statistic for 2x2 contingency table. What is ABCD? If I consider the table in the following manner, this position is your A, this position is denoted by B, this position is denoted by C, and this position is D. So it is your A value, this is your B value, this is your C value, and this is your D value. So I ask again, I am asking either Mahsal or Aniket or whoever is doing this particular. Okay, so I'm asking, Aniket is disconnected, so I'm asking Nahsal to apply this particular formula to calculate what should be the value of chi-square. Is it coming out as 10.09? Just try to find out what is the value of chi-square using this contingency table formula. 10.09 that we have obtained here by the usual rule of double summation over Nij minus Eij whole square by Eij, but you have applied this rule and you have calculated 10.09. So is it coming? Is this formula coming? Is this formula giving you the same value, 10.0916? You just check it. And quickly write in the table, quickly write in the chat box. Aniket's in Aniket area, there is some kind of problem. He has written a direct message to me that he is getting disconnected for some reason. He has got some sort of problem in his area. So Nasal is present, or anybody, Sudakshina or whatever, whoever is present, Srimanti is present and Shomili present, please try to apply this particular formula and tell me whether 10.0916 is coming or not. Yeah. So Nasal has already checked. So 10.09 is coming using the above formula. Using the above formula. Okay. Now, this formula is only applicable when the table is, this contingency table is of order 2x2. Let me now check whether Maple software can help me in this regard or not. Okay, so again, I'm sharing the screen of the Maple file. Just a minute. I'm sharing the previous screen, and let me try to solve the problem, this particular problem, using whether contingency 2x2 table contingency table is present over here or not. Let me check. So I will write here 2x2 contingency Just a minute. Okay, so this is the thing. You see, 2 by 2 contingency table, this particular page has opened. And they are calculating, they have shown the calculation. You see, can I change it? I don't know. These are not changing. So what we can do is that I don't know how to. No. Contingency table, the operation they have not shown. Okay. Show the expected values. Oh, just a minute. They here for a specific problem, for a particular problem, they have used. They are just showing you that they have written the formula of the contingency table, but they are not giving us any kind of code so that we can use it. This is the problem. They have just explained how this contingency table. Here in this, what is happening is that they, in this particular case, they have just shown what contingency table is and how we can use the chi-square goodness of fit using this particular formula in case of 2 by 2 contingency table. So first of all, they have calculated the expected frequencies, just like I showed you in the earlier cases, and they have explicitly calculated the chi-square statistic over here. Then they just have shown here that this can be done by using the contingency table of this form, and with the formula that I have explained just now, with the help of this formula, they are calculating their chi-square statistic and the degrees of freedom as well. But you are not able to apply it. You are not able. Chi-square statistic is coming out to be 0.20 for their example. And when they explicitly calculate it using this, they also got it 0.20. But I am not. We are not able to use it over here because you can see that you can only, if I consider the A value, you can only consider from 0 to 5. You can change it from 0 to 5. You can consider 0 to 10. You can just fluctuate between this range. Okay, so this application or applicability of this particular case is very limited. You cannot use it. And also, this formula that we have used just now is only is a limited is a formula which is limited to 2 by 2 case only. For any other rectangular case or any other higher square matrix, higher order square matrix, this will not be applicable. So it is better to use, if I want to do the calculation using, if we want to do the calculation of contingency table, it is better to use this particular rule that I have shown you over here. Okay, so it is better to use this formula, this command, to get the chi-square statistic for contingency table of any order. So this is all about the chi-square statistic of independence of attributes. Okay, and right now at this moment, I'm going to stop my today's session. Tomorrow we have session in the afternoon once again. Then there I'm going to discuss other features of hypothesis testing. So see you tomorrow. Till then, bye.